Hello and all right. Back to Calculus 3. It is the review day. So exam is on chapter 11, about 10 problems, right? So we talk about vectors and basic calculations with vectors, meaning adding, subtracting vectors, scaling them by multiplying by a constant, figuring out the direction of 2D vectors and also the magnitude. We're also talking about the cross and dot product, which is the way to multiply vectors, remembering that the dot product can be done in any dimension and the cross product only in certain dimensions, which one of which is 3 dimensions. The cross product is very useful. You have to know how to compute the cross product using that big matrix and the determinant. The big uses for the dot product is to find the angle between 2 vectors, and the big use for cross product is to get the normal vector. Now obviously they do much more than that, but these are the 2 most important. Then we have the equation of the line. It's a parametric set of 3 equations in terms of parameter t. Because of that parameter t, we have the orientation of the curve. We know that there is that vector v, which is technically a 3-dimensional slope for our line. And if you look at that equation, r equals r0 plus vt, it almost looks like y equal mx plus b, right? So where m is that v, and then x is t, and then that b was r0, and so on. Then we are moving into vector-valued functions, which allows us to draw some lines and shapes in space, 3D space. And we again use the common parameter t, and that's a new way to describe our vector r, right? Having the vector of 3 components, f, g, and h, all functions of t. So we can compute the value. If t is equal to 0, we plug 0 into each one of these functions and compute the location. The vector r is the vector that stretches to that location, and the point is the location. Calculus for these vector-valued functions is done, limits, derivatives, and integrals all independently of each other. So you get to take derivative 3 times, take the limit 3 times, take the integral 3 times. And for indefinite integrals, don't forget the plus c, which in this case is the vector c1, c2, c3. Unit vector, and then unit tangent vector and principal unit vector. You gotta know the formula that when you divide vector by its magnitude, you get the unit vector in a direction of the original vector. So make sure you remember that. And then the unit tangent vector and the normal vectors, they have their formulas. For instance, unit tangent vector is, anyone? Test is tomorrow. R prime of t divided by 9. Very good. Motion in space, I limit that to a 2D case, which is the formulas you already know from your physics class. And then we have 3 formulas for length of curve. I received, well, I believe that email was sent out yesterday or maybe even the day before, but I got it this morning, about a question on the homework which involved the exponential function on the polar curve. That problem sounded to me like being a problem that would end up being integrating some kind of hyperbolic function. So, you know, that's what you learned in Calc 2, section 6.10. I believe that was on a homework. So knowing the basic equation from Calc 2 for length of the curve, but also knowing the new ones that we learned this class, which is the polar and parametric ones. And then at the end we have the curvature. That was the last. You also voted not to have 12.1 on the test. So the exam ends with whatever, the 11.9 or whatever was the curvature. Yeah, 11.9. What happened? What did I forget? Now, do you guys have any questions? Or
yeah. I've got like maybe 3.
you're pulling up a quiz now, right? No.
Don't touch it, it's happening.
Get that iPhone away from me. It like burns, man. I
don't have
can't
the whole
see
problem.
this.
Here, you can.
What does it say? Consider the following trajectory a moving object, find the tangent. Yes, just do it.
I'm asking you to just do it.
Oh, these are the components. Yeah, we didn't cover that. Yeah, go sit.
What was on the quiz?
Well, you look at it in a book, and then monkey sees, monkey do. You have the formulas.
But that won't be on the test?
What?
Any other questions?
Yeah.
Yeah, we didn't get to it. Yeah.
How did you derive the length for the polar curve?
You use the formulas.
Would be f plus f prime.
Yes. So you have the parametric one that the L is equal to integral from a to b of square root of dx dt everything squared plus dy dt everything squared dt. Then you also have that x is equal to r cosine theta and y equals to r. Well, in this case maybe sine t would be good, but let's switch this to t's. This is for honors proof. Now have to understand that this is your f of, well, no, the formula says theta, so these are thetas. Right? So now just change these into thetas. That's okay. That's what I did. You can call parameter whatever. You can call it t, you can call it theta. And when you differentiate this to plug in, you are differentiating in respect to theta. So, but it's a product rule. So copy the first one times derivative of the second one plus copy the second one times the derivative of the first. And that's your dx d theta. Square it and plug it in. Do the same thing for dy. The algebra reduces down to the formula. That's all it is. It's 3-step manipulation with the lines that are 15 lines long. Because now you have to square that monster, and you will also have to do it for dy d theta, square it out again.
Yeah. Could you do an integration?
Maybe.
It's integral of square root 1 minus cosine theta. Okay.
Like this?
Yeah. Sure, you're gonna solve it in like one step.
Now where did this come up?
Like homework or something.
Because this sounds to me like you missed the square over here, which would turn it into sine square, which is the... No?
This is like part of one of those big step homework ones.
Okay.
I think Mathematica said to use one of the like half angle things, but it didn't really double angle, double half.
Yeah. Well, that's the only option. You have nothing else.
You know, the whole thing. But can you?
Yeah, because...
Explain it too well.
All right. So here's what... I mean, the other problem... I wanted that square because that is really easy in that case.
And it's just sine squared.
But if it's, yeah, sine squared and then square kills this and you just integrate sine and you're done. So the answer is negative cosine plus c. But Since this is the case, here's what you need to know. You need to know that sine squared x is equal to 1 minus cosine 2x over 2. And now you see that there is similarity between this and that. So now you already are comparing that your theta is equal to 2x. So that's the you can call it substitution if you want to. So now I am going to claim up there that 1 minus cosine 2x is equal to 2 times sine squared x. And because 2x is theta, I will say 1 minus cosine theta is equal to 2 sine squared theta over 2, because you can solve that x is theta over 2. So now that brings us to a problem that 1 minus cosine is actually 2 sine squared theta over 2 d theta, and that's a basic integral now because root 2 gets kicked in front, square kills the root, and you just have sine theta over 2 to integrate. And the integral of this is root 2, integral of sine is negative cosine theta over 2, but you also have to get the 1 over 1/2, which is another 2 in front. So the whole thing becomes negative 2 root 2 cosine theta over 2 plus c. And I'll just maybe point to this one over here and say 1 over 1/2. So what happens? I don't know. Test is tomorrow.
Did you write the test yet?
Tomorrow. So it's just using one trig identity. This is the power reducing formula. This is cosine 2x over here. Let me just fix that x. Doesn't look like x. So I just wrote the formula, and then I compared the green parts that look the same from where I picked up that theta is 2x, and then I just did the transformation. It's just plugged in things. Just rearranged the formula and plugged stuff in. That's all I did. After that, it was just basic integral. Yes.
I guess part 2 of the question. I plugged the original one into Symbolab, and it gave me this negative 2 root 2 over square root tangent squared theta over 2 plus 1 plus 6. I'm just, they should be equal, right?
Yeah, because you can probably do some of the, then you can go and work with a half angle formula for cosine and get it further. There's lots of beautiful mathematics that you can add to this problem if you want, right?
Wait, then that's just, yeah, okay. Oh, why is it doing this way?
Anything else? Yes.
How did you derive one for curvature?
The arc length.
Never mind.
No, go ahead.
No, well, it's in the book. He opens the book. It's 2 lines. You're just changing the arc length into parameter t. Those 2 lines, you'll find it there. Good? All right. George is here.
I don't know if it was just set it up wrong or. I don't get this part of it here. This would turn off. This, add it in.
It's a dot product. So you compute the dot product first, and then it's a dot product. So you have to dot.
Oh, so this is dotted with this. This is dotted with this.
Yeah. I mean, you distribute this into each one
Okay.
because it multiplies it, right? And then you
Oh,
find the derivative.
okay. So that's how you would get the U of t by itself again.
Look, 2t3 times this is 2t to 20.
Okay.
Boom. 20 goes down, times 2 is 40, t, and then 20 minus 1 is 19.
Okay.
Any other questions?
I have more if nobody else is going to ask.
No one is asking anything.
I don't want to like eat up all the time. I lost my track. It's not so much like a specific question, but could you go over that whole matrix thing you were doing for the cross products? Okay, can you, like, when you did the cross products, you did something with the matrix.
I did something. What do you mean I did? I just did the determinant of the matrix to find the cross product of two vectors. What?
Do we have to use that matrix, or can we just like skip straight to the chase?
Do you know how this the whole thing works without?
Well, I know the pattern. It's 1, 2, 3, 2, 1, 3, 3, 1, 2, positive, negative, positive. With the negative between each.
Whatever you said, if it works, I have no clue what you did, but
Alright.
no one cares. And seeing your steps,
Alright.
grinding the cross product to get a normal vector.
Now, if I solve something using physics, work through instead of using.
Such is your knowledge.
Okay. And can you also go over how we find parallel and orthogonal lines to certain vectors?
For parallel lines, your vector v, which is the slope, technically like 3D slope, has to be scalar multiple of the other one. So for parallel lines, you have vector 1 is equal to c times vector 2. So this comes from line 1 and this comes from line 2.
Right.
If they are scalar multiples of each other, that means that their lengths are different, but they have the same direction.
Okay.
Therefore, the two lines are parallel. For perpendicular lines, if line 1 is perpendicular to line 2, the dot product of their vectors is 0. Because we know that dot product equals 0 means perpendicular lines. So again, just like in your algebra class, everything is with the slopes. It's the game of slopes. You have, for two parallel lines, the slopes are the same in algebra. And for two perpendicular lines, they are inverse reciprocal, right? Negative reciprocals. So now you have, again, this 3D concept of a slope, which is the vector v.
Okay.
and that one decides whether the lines are parallel, perpendicular, or askew. The lines don't have to. So in algebra, in 2D space, the line could either be perpendicular or parallel or intersect. Over here you have the fourth concept as well. They could be parallel, they could be perpendicular, they could intersect at any angle, just like in algebra, and they also could miss each other in the in space. If this is one line, here's the parallel, here's the perpendicular, right? Here's any other angle, and then here's the skew.
Right.
They are not intersecting, right? So this is not possible in 2D,
Okay.
but it is in 3. Oh. And the only thing that governs what's happening is V, because the direction of V is in.
How do you know if the lines are skewed?
Vectors V, again, they don't have any common points between the two lines. They don't have a common point anywhere. Because any intersecting lines, the point of intersection is on both lines. If the vectors are skew, you are not able to find such a point that belongs to both lines. So you can assign, for both lines, you can assign x to be 1 and y to be 2, let's say, or pick whatever other values you want, and then just try to figure out if it's possible to make z's work. So there are many ways in which you can do that. You know, play with equations for 15 seconds. You should be able to see it. Yes.
Then the parallel one. Can C be any number or?
Any number from negative infinity to positive infinity.
Okay. All right.
Not 0, obviously. Not 0.
Any non-zero.
Any non-zero number.
Can you scroll back up a little bit?
Right. That's
A little
C.
bit more. That's it. That's cool about a considerable amount.
Yeah. What?
Yes.
You can be. You can just
For the
like.
equation you wrote, like for L1 to be parallel to L2, or not parallel, perpendicular.
Oh.
It's just
Okay.
V1
I gotcha.
dot V2, right? It's not V1 dot CV2.
No, just the regular V's.
You're a book. Okay. You got the book. Can you find one where it has
This is more like for the principal normal, principal unit only vector.
Tell me the chapter. Oh, sorry, perpendicular line.
That's, I just want to know what I have the equation down right here. That's the magnitude of key prime over magnitude of quad prime, right? Because I know that's going to mess me up on the next one.
You won't. No, you know it. Yes.
This one. Because 5 over 2 is going to make one of these 0 either way. That's correct. Once you take the derivative of it, or once you take the derivative of it to find the length, you're still going to wind up with either a sine or a cosine.
Yeah.
It makes one of them 0.
So
When you go to find a magnitude, that makes the denominator 0, doesn't it? No.
nope.
I'm thinking correctly earlier then.
Nope.
Or not.
Because you do the integral.
Right. Okay. Oh,
It's a length
that's
of
what
the
it
curve.
was. Because it's cosine. Okay. I think the everyone over.
Should we do it? Just in case?
Yeah, because well, cosine to the third is what threw me off earlier, and I think we figured it out later on. Because when you take the derivative of the cosine to the third, it winds up with
Square.
square, or you wind up in sine and cosine for both of these.
The question is to find the length of the curve given cosine cubed and sine cubed function. So, I believe that this shape looks like this. But not 100% sure, but I think that's what it is. All right, so how do we find this? We have the x component and the y component. We have our integral from 0 to pi over 2. And then we have 15 cosine squared t, 15 squared. No. Hold on. Derivative of this is 15 cosine, yeah, I had it right. 15 cosine squared t, everything squared, plus negative 15. Oh no, this one was negative. Derivative of cosine is negative sine. Negative, there we go. And this is 15 sine squared.
What happens to the sine when you take this?
I'm just rushing and then I'm getting things confused. The derivative of from scratch.
Wait, -15 cosine.
Negative 15 cosine squared t times sine t. There we go. Squared. Plus. Wow. Now, the same thing happens with the other one. We have 15 sine squared t times cosine t. Much better. dt. There we go. And that's squared. So now we square everything inside. So we use the basic chain rule from Calculus 1. And we have the basic derivatives there. Now, we square everything. We have a 15 squared, that's 225. And then we have 225, well, 225 cosine to the 4th t sine squared t plus another 225 sine 4th t cosine squared t, all that under the square root dt, integral 0 to pi over 2. The next one is integral 0 to pi over 2. I can factor 225 and then square root of that going out is 15. I have a cosine squared sine squared to factor out. And what's left in parentheses cosine squared t plus sine squared t dt, which is further equal to sine squared cosine squared. They can now escape the root because now it's multiplication under, but they cannot escape integral. So they stay as sine t cosine t outside. And this portion over here is 1, so I'm not bothering with that. dt. This becomes 15 over 2 integral of sine 2t dt. That's much easier to integrate that way. Well, you can use u sub if you like. So 15 over 2 integral of sine is negative cosine over 2 from 0 to pi over 2. That's negative 15 over 4. And now you have the cosine of pi minus cosine of 0. So that's negative 15 over 4. Negative 1 minus 1. That's negative 2, so 15 over 2 is the answer. Yeah.
Find a parallel vector to.
Hold on. Find the parallel.
Sorry, perpendicular.
Perpendicular.
Mixing them up. I feel like I should be able to have that on track by tomorrow. R equals 3. On a 4 common negative.
That's it. Find the perpendicular vector to this.
Can't find a really hard one. That's what I'm looking for. They're all.
All right.
I mean, if you've got,
It says find any perpendicular vector. All right. All we need to do is to find which dot product, find anything that the dot product will give it a 0. So you can assign 2 values and just make sure that the third one zeroes it out. So I will ask the audience to pick 2 numbers. This is going to be a magic trick, all right? And I will provide the third number, and there you go. We'll have a perpendicular vector. So the trick over here is to find, let's call it vector Q with A, B, and C, such that 3 times A plus 4 times B minus 2 times C is 0. So I will ask the audience to give me a number for A. I heard 100 first. I will ask the audience to pick something for B. 1003 one. And then, since you guys were so nice, I will ask you to compute C. There you go. So your vector will be, your vector Q, which is perpendicular vector, will be 100, 1003, and then whatever C you calculate to go there. So for perpendicular vectors, dot product has to be 0, and you are allowed to pick any value for any 2, A, B, or C. Pick any 2, and the third one must then be whatever the equation gives you for the third one in order for it to be perpendicular vector. How many perpendicular vectors are there? Infinitely many.
Yeah. 6 directions. I got one.
You can do this just by looking at it. It's a 4012. 4,312 cut in half.
2156.
Yeah.
Might be. I'm gonna go with his answer. It's the 5th. Also not. No. It's
And now you have to redo the quiz. I'm gonna go with his answer.
Alright, so
Oh, it's
it was,
priceless.
I don't know, something harder, which I can't fine. Would it pretty much be the same process?
It's always the same process. The concept of perpendicular vectors, whether those are numbers or functions, is that the dot product is 0.
Right, but like
Pick 2, compute third.
yeah, pick 2, compute thirds. Like if it was sine x, cosine x, tangent x, I could say 4, 3, and whatever.
Yes.
All right. Opposite direction is negative everything, right?
Times -1.
Yeah.
What was the answer? 2050.
2156.
2156. Yeah. Great. Any other questions, concerns for tomorrow? Are you banking on it? Yeah. 9 in definition. Yeah.
Are you taking points off if we forget to write the arrow over our vectors?
I should.
No, you really shouldn't. You should. It's crucial to communication.
Oh, obviously. Otherwise, it's just a constant.
Is it T hat or T arrow hat?
T hat.
What is the hat?
Unit vector. Unit vector. When you see vector u, it's just a vector u. When you see u hat, it's a unit vector. As soon as you see a hat, you know it's a unit vector in magnitude 1. That's why it's special, because as unit, it has a magnitude 1, and it's important because that vector technically would not change the values you're dealing with. It will just change its direction. Hour 20. Well, hour 25. Hour 20.
Force radius Oh yeah.
Any other questions? Any other problems?
Wait. He's got one.
Why does the chain rule apply to vector value functions?
Chain rule applies to functions.
Why is it, sorry, cross products and dot products?
Because they're vectors. Well, the cross product doesn't apply, if you want to think about it, doesn't apply to a function. It applies to its value. You see, if you say y equals f of x, right? What you're covering there is infinitely many ordered pairs that where x is the input and y is the output. So if I say that y is equal to x cubed, then if I bring in x equals 0, y is 0, x equals 1, y is 1, x equals 2, y is 8, and so on. Now, if you have a vector valued function, and this is why I pointed out so many times the difference between r and the point. So you have vector valued function, and let's say it's defined as 2t, and then number 8, and then t minus 1. All right, so this is it. And then you have another function, vector valued function. What does it mean, the cross product between them? So let's say I have another function q that is given as 4 negative t and e to the t. Observe that all of this is dependent on t. What do I have at t equals 0? I actually have that the vector r at t equals 0 is 0, 8, negative 1, and I have that the vector q is 4, 0, 1. That's what I have at t equals 0. I can do the cross product between these, so I should be able to do cross product between these as well. So I can pick whether I want to first do the cross product with functions and get a vector that will still have functions, and then keep plugging in t1, t whatever I need, or I can first plug in t over there, figure out what the individual vectors are, and then do the cross product. But it's much better to do one cross product than this. Why does the cross product and dot product apply to this? It applies because these are vectors, and whether we populate them with functions or with objects or whatever, the cross and dot product apply. Cross product applies obviously only if it's appropriate dimension for it to apply.
What I was asking was how does the chain rule when you're taking derivatives? Why?
These are independent functions, and each one, components inside the vector valued functions are independent functions that you know from Calc 1. Chain rule has to apply because the chain rule, again, property of the function is something that you cannot change down the line because you have a new mathematical concept that is more general. So once you established that, let's say, this type of behavior is moving function 1 unit to the right, there's no way of changing that down the line to fit a different concept. So the chain rule is the property, right, for differentiation, which must remain in its place no matter how much layers we add on top of that mathematics. It applies here, it applies in tensor calculus, it applies everywhere. Yes? The cross product always gives us the perpendicular vector to the two vectors you started from, yes. It's perpendicular to the surface which the original two vectors create, which is very interesting to think about that as what happens as functions, because the functions, those functions, depending on which t you are picking, will be wobbling the plate a lot, right? And that will really wobble the cross product vector that you get. But you see that as soon as the base vectors change, because t changed, the cross product, which was also dependent on the same t, must change immediately. Other questions, concerns?
You won't need to know about normal vectors, right? You're going to need to know about them.
You know the normal vector formula, I hope? Good, that's it, you know it.
Or is it going to be on the exam?
The principal unit normal vector has to be there.
So it includes 11.9.
Yes, curvature is there, and principal unit normal vector is there.
How is curvature derived?
I told you those 3 lines in the book, 2 lines in the book. For the 5th time. What? Okay, so since you are since you are so nice, I'm actually going to tell you the page where you can take a look. Again, that's the part of the honors option. So I'm not going to. You will go to page 842. You take 8 divided by 2 and divided by 2 again.
Is that for everyone or just
No, it's for him. Now we have 3 students who are taking the honors option, so their exam includes proofs on top of what you do. Yeah, 3 students signed up. Yes.
distortion gonna be on it?
What about torque? What about, no, torsion, is torsion the same as torque?
What?
Relax.
Is torsion the same as torque?
Any other questions, concerns? Yes.
Will we have to like graph things?
Well,
Something's there.
what do you mean graph things? What are the things?
Like
Graph a vector?
media,
Why not?
like graph.
That's next exam, not this one.
Also, we don't have to graph.
On this one, yeah. Next exam contains 12.1 when you have the shapes and stuff.
Okay, because on the homework practices, there were like questions where they asked us like pick one of the 4.
Yeah, let's pick one of the 4.
Is there multiple choice in this exam?
Nope.
So it's all open-ended.
Yeah. Because multiple choice is switches on for maximum points or switches off for 0 points because you either circled C or you didn't, right? That's why the multiple choice exams are terrible. Unless you have 80 questions, like, I don't know, anthropology exam. Then in that case, with moderate knowledge or some knowledge, familiarity, and by the principle of the limit, central limit theorem from statistics, you have to pass every exam. Yes.
So for the motion, we would have to like, for example, are we responsible for calculating like time?
2D. You got that derivation that I did in class, so you know there's only acceleration and velocity and position functions.
Okay.
Anyone else? Questions, concerns?
What formulas from Calculus do we have to know and like the trig formulas? Because you said we have to know the double angle.
Well, power reducing formula is the most important one with the sine and cosine squared, because if you don't know those, you can't integrate. If the integral of sine squared pops up, the only way to integrate that is to know the power reducing formula. That's the one that it's for calculus. Obviously, trig, we just did Pythagorean identity for trigonometry, sine squared plus cosine squared, but you also have the one with the tangent and secant. Calc 3 is not that trig heavy. It's very, very light trig.
Wait, because on the notes in the slides, I think you had sine squared of theta equals, so that sine squared of theta equals 1 minus cosine of 2 theta.
That's the one, yeah. Those ones you always have to know, because the sine and cosine power reducing formulas are the only way to integrate. Since you are not allowed to have Wolfram alpha on the exam or calculator on the exam, there is no way to integrate those functions in any other way other than using those.
So no calculator at all.
You can bring the basic calculator or the scientific one that also does trig and ln's if you want to.
Do we need to?
No. It's Calc 3. You show up with a pencil.
I like the bird one, the golden bird one. Nice sticker.
Yes,
Can you extend the homework?
of course.
Like, yeah. The date of the homework, not the homework themselves.
Ooh, that's actually, wow, next time someone asks me, I'll just say yes, and then when they show up next time, there was like, why do we have now 50 problems and deadline didn't move? I will actually go in and just add another 20 problems. Can you extend the homework? Wow. You just gave me an excellent idea. Thank you.
Yeah, can you extend the due date of the homework?
Oh, the answer is yes.
Okay. For like all of the chapter.
Now he's asking much better question. Will you extend?
Oh.
See?
You're gonna hit him up with that grammar?
No, I'm not hitting up the grammar. I'm just a foreigner who barely speaks the language, so I have to figure those things out. I always said, can I, and they say, may I, right? I said, all right, fine. I finally learned what may means. When's the lab due?
As soon as possible.
But as a class, not as soon as possible. You are done and can in.
What's the final?
Thursday, 29th of June, I think. 29th is Thursday.
29th of June?
Monday after that, right?
No,
4th of July.
yeah, I know. Oh, 4th of July would be nice. What's that? Yeah, I know. What do you think, Tuesday? Not tomorrow, Tuesday. But
Tuesday is tomorrow.
how about we say a week from today?
We're halfway done.
Well, wait. How far does the lab?
On Monday, you will have the half of the course, and with one lab and one exam covered. Guys, Monday is the halfway through. Actually, no, Thursday is the halfway through because the last Thursday you have the final. Yeah, Thursday in 3 days is half of the course.
We might actually vote on not having an exam.
Yeah. Any more questions? So I end the stream.
Oh, is the stream still going?
Yeah.
Oh, cool. Hi, stream.
I guess no more questions. I'm gonna end the stream by stream, and then we can talk about the particulars of stream.